introductory words from my side. Nothing, again, nothing so compromative. How to pronounce it properly? Compromate? No compliments from me about Erwin. Just some inside information that Erwin bought a new road bike when Corona started, and gave himself a goal to go for a ride or walk every day for at least half an hour to get some fresh air and be away from the desk. Actually, you know, I have something similar goal. I'm running 3 times per week, and then I try to walk out just every week. So maybe we are twins or something like that.
Yeah, could be. Yeah, I mean, I used to get out a lot before the Corona crisis hit. I mean, you weren't allowed to go anywhere basically. So I was like, yeah, we need to go out as developers. I mean, everyone already thinks within a dark room all day long. So yeah, really time to get some fresh air.
So, okay, you're welcome on stage. Applause for you. I forgot to say thanks to Jan previously, so thanks to Jan as well. And now stage is yours, Erwin. I will not mix in, just will follow Q&A if something shows up.
All right, sounds good. All right, so welcome everyone to the second session. So for the next 45 minutes or so, we're gonna talk about the networking side of security. So we're actually gonna extend Jan his talk on security and see how we can make things even more secure with all the networking stuff that Azure has to offer there. So before we dive in, my name is Erwin Staal, and I'm an Azure architect and a DevOps consultant, and I work for the same company as Jan does, 4DotNet. We already had a little discussion during the break on what that name actually stands for. As you probably can guess from the name, we're a company who does everything on the Microsoft platform. So that's Azure, that's .NET, it's also training, etc., consultancy. So I'm from the Netherlands. I live in this beautiful place called Assen, which is quite up in the north. We're not really famous for anything, so you probably don't know Assen at all. But at least now you know where that is. Right, so before we dive into the details of how you can actually make your stuff in Azure more secure, let's spend a little bit of time on why would you actually want to do this? Why would you actually want to invest time in getting a network up and running, etc. Because you often, for most of the stuff in Azure, you don't get networking by default. You have to do things for it. So you probably all have created an Azure SQL database in the cloud. And one of the things you then have to do if you want, for example, your web app, like the ones Jan used in his demo, if you want them to be able to connect to a database, you have to go into the firewall settings of the database, and then you have to modify one of these switches here, which says allow Azure services and resources to access the server, the third one. You probably will set that to yes, because that's the easiest way in which Azure services can actually access your database. Otherwise, you would have to use IP restrictions. So, but by doing that, you actually open up your Azure SQL Server, your firewall, to kind of the whole of Azure, not just your applications, kind of anything. So, of course, there's still a connection string needed, which has a password. But if that password ever gets leaked, then anyone could spin up something on Azure and connect into your database. So there must be more here that we can do to secure that, especially if there's high confidentiality data in that database. So another reason why you might want to look at networking is one that I came across quite recently, and that's about compliance. So the diagram you see here comes from the Microsoft documentation on the credit card payment standard, the PCI DSS, which stands for the Payment Card Industry Data Security Standard, which is a compliance regulation standard in place, which is used worldwide. And what you kind of see here is the segmentation that has been put in place in the architecture, in the landscape. And as you can see, all of the crown jewels, the data, all of that stuff is actually in a particular network far on the right. Which means that if a hacker would want to get in, they have to start on the left, on the internet, and have to make their way through all of these security barriers in between before they can actually access the data. So that's a way to secure things. Just add additional hubs in a way to make sure that people can't get to your data. So we can, as you saw in Jan's presentation, do that on an application level. And on a user authentication level, but we can also do that on a networking level. So that's what you will see today. And then Azure can actually help you a bit more there, because we talked really about this PCI DSS compliance standard. If you would go into Azure Security Center, then you can actually find a blade that's about this compliance standard, and it will actually tell you where you are and where you are not compliant with this standard. And as you can see in this example here, it actually tells you that you should enable network restrictions on the networks that on the subnets that your applications actually live in. So that comes in handy if you want to be able to become compliant with one of the standards that you see here, because not just the PCI one, there's also the ISO, for example, which is quite well known. So the Security Standard Center can help you get compliant there. So our goal for today is to set up some infrastructure that you see here in this poorly drawn diagram. This is the only one I actually created myself in the whole slide deck, so that's why it looks this way. It's kind of what Jan did in his presentation, like we have a UI, a front end, which connects to a backend, which is the API here. And what we're going to try to do is we're going to make sure that our API is the only application that's allowed to access our SQL database. And we're going to make sure that no one else, not over the internet, not through any other way, can access our data. And then we're going to make sure that the UI is actually the only application, the only thing that can access the API. We also want to restrict access between those two. So the API as well is not reachable over the internet, only via our own subnets and our own networking stuff. So that's the goal for today, to have a UI that's allowed to connect to the API and have an API that can connect to our database. And then we have to begin to start with virtual networking. And you can use a virtual network to group your resources and to restrict access to them or restrict access from them. So it's inbound traffic and outbound traffic that we can restrict. So a virtual network has an IP address range, which you can specify when you set it up. And in Azure, you get to choose from the private IP ranges that come from the RFC, the well-known one. So you can pick a 10 range, a 172 or a 192 range, and use that for your subnets or your virtual networks. So in a virtual network, you can set up one or more subnets to be able to group your resources even further. Microsoft does advise to not create too many of them, because if you create a large amount of virtual networks and a large amount of subnets in them, you also have to manage all of that stuff. And one of the things you need to think about is that it's quite hard to change the address range of a virtual network and of a subnet. So you can't really change the address range of a subnet after you created it. You have to go through a few loops to get that done. But most of the time, it simply can't do that. It's simply impossible. You can change the address range of your virtual network, but only if all of the IP addresses you are using in it are still available after you make the change. So it comes with restrictions there, so you need to think about that. They also advise to not make your subnets and VNets too small because of that very reason. So if you create a subnet in Azure, then you get to pick how big it should be. And the smallest you can go is a /29, which will give you 3 hosts. Normally that would be 8, But in Azure, that's 3 because Azure needs 5 IP addresses from each and every subnet you create. And I've listed here which of the IP addresses belong to Azure and which you can't use in any of the subnets you will create. So what you can also do is you can also link these virtual networks together, which is what we call virtual network peering. That allows resources in one virtual network to access resources in another virtual network. So you can add a connection between the two. You need to be aware there that if you want to do that, then both the virtual networks need to have different IP address ranges. Otherwise, you can't send traffic between the two because it doesn't understand where to send it to them. So you can connect the two, but you need to make sure that the IP address ranges do not overlap there. All right, let's go to the Azure portal and let's create our virtual network to see what that actually looks like. Before I'm going to do that, I am going to quickly show you the setup I created for today. As you see, there's already quite a few resources in my resource group. Let me quickly sort them by type. There's the 2 web applications I talked about. So there's the UI and there's the API. They obviously run on an app service plan. And then down here, there is the SQL-server, which we are going to protect later on. And as you can see, I already created the virtual network for the UI. So let's go about and create the virtual network for the API. You simply select it from the list over here. And the first thing it wants is to get a name. So I copy that one and I'll rename that to API. And once you select the location where you want to host your virtual network in, and this is quite important because later on we're going to use the web application. We're going to add the application to the virtual network, and there are some restrictions on how you can do that. And the basic rule is that if you want to add something to your virtual network, it needs to be in the same region as that virtual network. That's not entirely true all the time, but it's true enough for now. All right, so I added my name here. So on the next page, we get to pick our address range. So today I will go for this one, and I guess a 24 here will be big enough. So we need to add a few subnets here. So let's add a default one, and I'll explain you later why. Pay attention that Azure just gives you here how many of the hosts there are available. Normally there would be 64, but because of the 5 reserved ones, you end up with 59 IP addresses that are usable for you. All right, so we're going to add another one for the web app. So that one has to start at 64. So, and that's kind of what we have to do for a virtual network. You select the address space for the entire network, and then you add 1 or more subnets, and you specify a range for them. All right, so there's a few additional steps here, but we're not going to change anything out of the default there. So I'm just going to hit review and create and get that deployed. Normally creating a virtual network is pretty quick. So there we are already. So that's been done then. Let's move back to the slides for now, and then come back later in the portal to do the next step. All right, so now that we have our virtual networks in place for both our UI and our API, let's have a look at how we can lock down, how we can secure our database. Because that's how we're going to do it today. We start with the database, lock that down, make sure only the API can access that, and then we're going to lock down the API to make sure only the UI, our UI, can access it. So let's start with the database here. And we're going to use a service in Azure, which is quite new, which is called Private Link. And what Private Link does is that it gives you a private connection, private endpoint to an Azure platform as a service offering. So it allows you it will actually give you a private IP address in your virtual network that allows you to connect to, for example, a SQL database or a storage account or almost any of the other platform as a service offerings Azure has. So it's important to know that you then, if you do that, you no longer have a public IP address to that particular service. So you do lock it down by doing that to only your virtual network and to only that IP address that you get in your virtual network. So another nice benefit is that traffic then remains on the Microsoft network. It doesn't leave the Microsoft backbone anymore, and so it doesn't go over the internet. So it becomes a bit more performant and also becomes a bit more secure. It does allow you to also integrate with on-premises networks. We will see later on how. And we already talked about peering networks, the peer networks, so networks you connect with each other. You can also use the private endpoints from another virtual network when you have that paired to this one. So there's quite a big list of services in Azure that already allow you to add a private link. Most of them are already generally available, but some are still in preview, as you see over here. And the list gets bigger and bigger almost every month. So one of the resources that I use a lot is the Azure Web App, which is on the bottom of this list. And as you can see, it's still in preview. So we have to wait for a while to get that general available. But one thing I did want to note about it is if you want to use a private link later on the Azure Web App, your Azure Web Application, or actually your app service plan, needs to be on a premium tier. So if you want to add a private link to it, and you aren't already on that premium tier, it is going to add a few dollars to your Azure bill. All right, so let's head back to the Azure portal, and let's see how we can add the private link to our database server. So let's go over to our database. And before we're going to add the private link, we are going to the firewall and virtual address blade to lock down and deny access to our database from the internet. So as you can see, the denied public network access is set to no. We're going to set that to yes because we want to deny public access. We only want it to be accessible over the private link. And we're also going to switch this one, the allow Azure services and resources to access the server, to no, because we only want to have these databases again be accessible over the private IP. So I hit save here, and it will get saved. That sometimes takes a while, and the thing is that you're not allowed to move away from this page, otherwise it simply won't work. So let's hope it's a bit quick today, so we can move on. There we are. All right, so although it did say it saved it for now, you will probably see that if you go here and it's already not working anymore. It sometimes takes a while for the firewall rules to actually get in effect. So if you switch things here, take your time between checking it again to make sure it actually works. All right, so let's go to the private endpoint connection blade and hit add private endpoint over here. It again wants a name, so let's call this one SQL private endpoint. Again, the location is important, so we're going to choose Western Europe again. It now wants us to connect to select the resource we want to connect to, and in our case, it's going to be a SQL server. So we're going to connect to a SQL server, and this is the one I actually want to connect it to. And as you see, we're actually going to select the SQL server here, not the DB itself, not the database itself. So that means that every database that you host on this particular server is accessible over this private link. So it's on a server level, not on a database level. That's important to know. All right, next up, it wants us to select the virtual network to put that private link in. So it's going to be the API one, and I don't want to have it in the web app one, but I want to have this one in the default one. So I select that. The next one is a question on the private DNS integration, and it's on by default, and you actually want to leave that on because this will create you a private DNS zone, which later on will allow our web application to connect to our database. So what this does for you is that you don't have to connect from your application to a database using your IP address. You can just use the connection string you're used to. just the host name like you used to. And because of the fact that you introduced the private DNS zone here, it will later on still be able to find your IP address, your private IP address, instead of the public one. So we're going to leave this DS, and this is actually the right subscription, and it's going to create me a new one, which looks okay. All right, so we had review, and we hit create, and this will make sure that the private endpoint gets created. All right, this one will take a while. It has to create several resources in Azure, and especially the private DNS zone takes some time sometimes. So while that's ongoing, we move on to the slides and look at the next thing we're going to implement in Azure. Because what we've done so far is that we have added our database to our virtual network. So our database gets a private IP out of our range. But now we need to make sure that our API actually uses that private IP. And we can do that by using something called the Azure App Service Virtual Network Integration, which means that you're going to put your Azure App Service into a virtual network. And what you have to know is that it only does that, it only uses that virtual network for its outgoing traffic, so for egress, not for ingress. We have something else for that. We will look at that later. It's important to know that the VNet integration is only for outgoing traffic. And what it does is it will allow you to access resources in your virtual network in the same region. That's important as well. If you do VNet integration, especially the regional VNet integration, you will not be able to access anything outside of that particular Azure region. You will be able to access stuff in that particular region. It does require a standard or premium V2 app service plan. So again, cost might go up if you weren't already on one of the two. And you would actually then block outgoing traffic with a network security group. So you could make sure that your application is only able to reach your database and is not able to reach to anything else on the internet with the same thing. There are a few additional app settings on your app service that you need to set before the connection to the database later on will work. But I'm gonna show you which two that are and how you can set it up. So let's go back into the Azure portal. And as you can see, this is actually still ongoing. Let's hope it's done when we've added our API to our virtual network, because that's what we're going to do now. We're going to the API, we're going to the networking blade on it, and we're going to click here to configure on the VNet integration blade. So we hit add VNet, and we're going to have to select the proper virtual network. So again, you see there's a few in the same region, but there's also, I don't have any right now, but you could select one that's in another region, but that requires a bit of a different type of integration than the one we're going to use today. So I'm going to select this one, and here we can select an existing subnet. And as you can see, it already kind of tells you that I can't use the default one that I just used for my SQL database. That's because I have to create an empty one. And that is because what actually happens here is that by doing this, you kind of give this subnet to the Azure App Service. You kind of say, here is a subnet, and you may have it, use it for this type of integration. It's called delegation. And with that comes the fact that you can only use it for this particular delegation. And you can also only have one app service plan in this particular subnet. So you can't connect another one to it. It's just a one-on-one relationship with an Azure App Service plan. What you do need to think about when you create your subnets in which you are going to put an App Service plan is the following. When you scale an App Service plan up, so you add more instances to your App Service plan because you need a bit more performance, at that moment in time, you need twice as much IP addresses as you normally do. So let's say you scale up from 10 to 20 instances. At that moment in time, you actually need around 30, I guess so, 30 or 40 IP addresses. So keep that in mind when you create your subnet for your app service. You need twice as much IP addresses as the maximum number of instances that you would want to scale. That's important. All right, so we pick the web app one, we hit OK, and that will actually do the integration between the two. As you can see, it's already done. All right, so as I mentioned, there's one last thing we actually have to do to make this work. Let's see if it already does, by the way, because this should now normally it does. All right, so there's two settings we need to add for this to actually work, and I've already done that here because otherwise you see me typing IP addresses, etc. You don't want that. So the first thing you need to add to make this work is the website DNS server one, and you need to add the static Azure DNS IP address. This is because by default, the Azure App Service doesn't connect through a private DNS zone. And as I explained before, we're going to need the private DNS zone to actually be able to get the private IP address. So by adding this configuration setting with this IP address, it will actually use the private DNS zone later on. Then there's another one, which is this one, the website VNet root all. We've set that to 1. So by default, if you do the VNet integration, then only connections made to private IP addresses, private ranges, are going to float through your virtual network. So all the other traffic is not. And that's why we need to add this setting, because we want to have all the traffic flowing through our virtual network instead of just the private ranges. So we add this one, and that should help us out here. All right, so let's see if it actually works, because, there we are, it does. So as you can see, we're up and running again. We can actually do one last check to validate how the connection is being done. So we head to the console here on the app service, and I'm gonna copy paste a command if the console actually works. There we are. So what we can do here is we can use the good old name resolver tool. I'm on a Windows server here, so that's why that works. We can use the name resolver tool, and we can actually use that to resolve this particular address. And if we do that, then you see that the address that's returned over here is actually the private IP, the .4, that comes from my subnet. So if we would have done this before the integration, you would have seen the public IP address, which is somewhere in the 13 range, if I'm correct. And by doing this, we now actually get the private IP address of the actual service. And as you probably noticed, I haven't changed the connection string or any other thing in my app. That just works. So that's pretty cool.
Erwin, sorry,
Sure.
Can you make font bigger?
Sure. At least I guess so.
Yeah, thanks.
That's better, right?
Yeah.
All right. So yeah, once again, here's the IP address, our private IP address. So that proves that this actually did work. All right. So what we've done so far is we've added a private IP address to our SQL server, and we've made sure that our API is accessing that SQL server using that private IP. So let's head back to the slides to introduce you to a few more concepts to do the security between the UI and the API. So the next quite new addition to the Azure networking things in place is service endpoint. And a service endpoint allows you to provide you a secure and direct connection to Azure services. So what that does is that if you have, for example, a VNet, so the UI VNet I already created, we can add a service endpoint to that UI VNet to, for example, the Azure App Services. That's what we're going to do later on, because we want to have it connect to our API, which is Azure App Service. So that provides a secure and direct connection from our UI subnet to the Azure App Services. And again, if you do this with a service endpoint, just like with the private link, the traffic from your virtual network to your Azure servers remains within the Microsoft network, making it a bit quicker, making it a bit more secure. By doing this, by adding a service endpoint to this particular VNet, like we're going to do later on, we can lock down access to that particular VNet, as we will do with the API. A difference here, opposed to the private link, is that if you use a service endpoint, you will still be using a private, the public IP address, and not the private one as we saw before. So traffic is not actually flowing directly through your own networks, it's going through Microsoft network and using the public IP there. So what's actually happening under the hood is that when you add a service endpoint to a VNet, it actually adds a route to the route table that belongs to that VNet. So this, for example, is the route table of a virtual machine. And as you can see, a row has been added, which also says the next hop is the virtual service endpoint. This is actually has been a service endpoint to a SQL server, to SQL. So what they did here is they added the entire range of IP addresses that belong to the Azure SQL service as a route in the virtual machines route table. So that's how that then knows how to more optimal route that traffic instead of what you would normally do. So let's see how we can implement that. But before we go into the portal again, here's a list of all of the Azure services that have a service endpoint available to it. Most of them are generally available. Only the one on the bottom, the Azure Container Registry, is not. The other ones are production ready. All right, back in the Azure portal. Let's head over. Let's make it a bit more. All right, so what we need to do now is we need to add that service endpoint to the subnet of my UI, because what we want to do there is that we want to have this direct and performant connection between our UI subnet to the API, so to the Azure App Service. So that's why I already, before the demo, added the Microsoft.web service endpoint to this virtual network. It sometimes takes quite a while before that comes into effect. I have seen situations where it takes up to 45 minutes. That's long after I finished this demo. So I already did that before to make sure it works and it's actually in this demo. But that's all there's to it. You can go to your subnet and you just hit the button, hit the checkbox to the service you actually want to connect to from this subnet, and Azure will do the rest for you. So with that in place, it's time for the last bit of configuration we need to do to make sure that only our UI can connect to our API. To do that, we're going to use something which is called the access restriction on a web app. So we're going to lock down our API to just a specific virtual network, because that's what you can do with the access restrictions on a web app. It allows you to define a priority ordered allow deny list that controls network access to your app. So it's kind of a firewall list on your Azure web app. And you can add these lists, these rules by adding IP addresses that you do allow or do not allow, or by adding virtual networks that you do or do not allow. So let's go into the portal. Let's find our API and let's see what that looks like. So again, we're going to the networking tab of the API, and we're going to the configuration section on the bottom here, the access restrictions, and we hit configure access restrictions. So as you can see, there's now one rule, the default rule, which says allow all. So by default, if you create an Azure App Service, everyone from everywhere can connect to your app service. So we're gonna say add rule. We're gonna call this one the UI. We give this a priority. It's the only rule we're going to add, so it doesn't really matter for now. We're going to pick virtual network as its type, and it already selected on it. This is actually the wrong one. We need to select the UI virtual network, and then we need to select the subnet in that virtual network that we want to allow access to this API. So we're going to select the web app. That's simply the only one that exists in that virtual network. So it's been added. So let's see if it actually works. This by now should give a forbidden, which is correct because we have just said here that only the virtual network that our UI lives in is allowed to access this API. So I'm no longer allowed to do that from my home IP. But this UI normally should have still been working. We actually forgot something here. Let's quickly go back. I think, at least, that I forgot to add this one, maybe to my, so we are on the UI application here, and I forgot to add this one into a virtual network. So this is the same network VNet integration as we did on the API, but I forgot to do it. So let's add it here and make sure that integration has been added as well. Let's hope that's a bit quick. Well, let's go back to the API then, because I wanted to show you one more thing over here. Let's go back to the Azure access restriction blade. So we added our rule here that says allow traffic from this particular subnet. What Azure then does is it also adds another deny all rule to the list as well. And this deny all causes this forbidden error over here. So I now added this particular rule to this domain name, which is the API. You can also do it, add restrictions on the management side of your Azure web app by adding them in this list. So that is something you probably always want to do. You probably always want to lock down your management side to, for example, the IP address of your office, something like that. All right, let's do one more check. And there we are. It works again. So now we have our UI being the only thing that's allowed to access the API, because that's how we've been setting things up here in the networking stuff. So that's cool. Let's go back to the slides for the last few things. So you might now be wondering, now that we've been locking things down, me no longer being able to access the database from my home, my office, no longer be able to access the API from home or from office, but you do need to be able to access that, right? You do need to be able to debug stuff, to get into your database, to verify things, for example. So you need to figure out a way to gain access again there as well. So the most simplest option probably is to add your IP address, your office IP or your home IP, to all of these deny lists and firewall rules that we've been setting in place. That, however, is not really handy, especially in the current COVID situation where everybody works from home. So you would have to add quite a few IP addresses there. Home IP addresses might actually change over time. If I unplug my router, I will probably get a new IP address from my provider. So that's not really ideal. So what you could do here is add something called a VNet gateway. Actually, you want to add a VPN connection into your Azure virtual networks, and that can be done with a VPN gateway. That allows you to send encrypted traffic from and to your virtual networks, and that could be both virtual networks in Azure, so in multiple regions in Azure, but it could also be from your office location, from your home location into your virtual network. So there's a few different options here. This one is the site-to-site version, where you connect your on-premises office to an Azure virtual network using the VPN gateway. This is an example of a multi-site version, where you simply have multiple offices, multiple buildings which need to connect to the same VPN gateway. We also have the this is this VNet to VNet connection. So if you have multiple Azure regions and you want to be able to connect between the two, then you could use the VPN gateway to set that up, to securely connect, privately connect between two virtual networks and two different Azure regions. You can also use ExpressRoute to get a more private connectivity into your virtual network, or to simply add an additional connection to it. You might use that next to your normal internet connection as a backup, for example. Or actually, probably you will then be using your service provider's connection as a backup and your ExpressRoute connection as the default one. So that's an option as well. And probably the simplest option is the point-to-site VPN. And in that case, your clients will access your VPN directly. So in all of the other examples, you will have some virtual network, some VPN appliance in your network that does the VPN connection for you. And in the point-to-site one, you will all of your clients will have a VPN client installed on their device, for example, that connects to the VPN gateway. So that could be their mobile phone, it could be a laptop or a desktop, that doesn't really matter. Point is that they all use their own device to connect straightly to the VPN gateway. There's a few ways in which you can protect and authenticate that connection. One is a certificate, in which you have to hand out certificates to the clients, and then they can use that to connect. You can use the Azure Active Directory to do a user-based connection there. But it's also the Radius protocol and also the Open VPN protocol there is supported. At my current client, we actually went for another option because there's another option as well, and that's to use a product by a third party. So there's also third parties who allow you to do VPN connections and even more into Azure and get that secure connection going. So we went for a company called Kato Networks, and they have various solutions to this problem, which we now have in place. So the first thing we have by them is the VPN connection. And Kato actually has entry points to their network all over the world. There's almost 50 of these point of presences over the world. What that means is that when I connect my VPN, that will actually find the closest point of presence of Kato, and from that point I will be going to Azure over the Kato backbone instead of over the internet. So that gives me a more secure, more stable, more performant connection than I would get with a normal VPN connection, which would go over the internet all the way to Azure. So that's one of the benefits of going with a solution like this. But another one is that when we do get into Azure, we don't get into our virtual network right away. There is something in between called a next generation firewall. So that's a firewall which has some additional features to it. It scans the packages for malicious content, etc., and blocks it if it needs to. So before we get to go into the virtual network, our traffic is actually being scanned there as well. So that's a pretty nice option there. Another benefit we get from them is that when we use their VPN clients, we also get a few static IP addresses. And that means that whoever connects from their VPN, from home or from office or from anywhere, doesn't matter, they always come through one of those IP addresses. So that allows you to use those IP addresses on other services to do whitelisting. So for example, you can do IP whitelisting on GitHub since quite recently. So you can now use the IP addresses of your VPN connection to whitelist yourself on GitHub and make sure that you are the only one that can access your source code on GitHub using your VPN connection. This of course comes with a cost, but it also has a lot of benefits in terms of security, and it's up to you to figure out if you need that, if it's worth it. We also get this very nice portal from the product in which we can see a lot of things, stuff that's going on, how much traffic is flowing through our VPN connections. We get to do a lot of setup, etc. We can specify which traffic has to go through the VPN and which traffic does not is not supposed to go through the VPN, or which traffic should go directly into Azure and which traffic should not. So really cool product if you want to do a bit more than the standard VPN connections you basically get from Azure. All right, that's what I had to tell you for today. If you have any questions after this session, you're obviously free to ask them right now. But if you have any questions later on, then this is my Twitter handle. That's probably the easiest way to get to me, or find me on LinkedIn and ask your questions over there. So let's see if there actually are any questions.
There were some questions already while you were talking. Do you see them?
Yeah, let me switch back to Teams here.
Something. Oh.
You add them to the published one, the published list, I guess. Eh? Yeah. All right.
I published 4 of them at the same time, so I'm not sure about order. So maybe they were written in a different order.
Right.
It's 728.
Right. The 628 is probably all right. I think they're right in the juicy part of the onion. Web the sysadmins with the most privileges hire some creep fine. Yeah, that's not really a question, I think.
Then let's go further if it's not really a question.
What tool do you use for provisioning configuration management? I think that's the first actual question in the list. That's by Andrew. That's a good question. At my current client, we're actually using the Azure Resource Manager templates. So the ARM templates to do all of our provisioning. So that means that all of this stuff I've been showing you today, most of that's being set up through these ARM templates. Sometimes there's things you can't do with the ARM templates. So in that case, we do things with PowerShell or the Azure CLI. But most of the stuff we do is the templates. And we do have the rule that you are not allowed to make any modifications in the Azure environment unless you do them through the templates. So that's quite important. I hope that answered the question. Do you run any tests to verify security policies against real infrastructure, not just Azure configuration? Do you need a permission from Microsoft to run that sort of red team operation test, even against your own? That's a good question. We do not. We do rely on the Azure Security Center that I mentioned before. So we don't have actually tests in place to verify if the network is actually closed, for example. We do rely on the security center there. So there will be a no. And yes, I have worked at another customer who did want to do pen tests, etc. And especially if you are going to send a large amount of traffic, etc., then Microsoft do want to know, then they would like to know when you start DDoSing them. I'm not sure if you really have to. It's probably in the agreement that you have to, but I'm not sure. But it's just nice of you to announce that to them, I guess. Can you use private link to establish HQ connection to your partners, etc. infrastructure? All right. Yeah, you can use private links to connect to partners in that sense that you could. What private link does is that it allows you, it gives you a private IP address in an Azure subnet. So it's not the private link itself that you could connect to a partner, but you could use the VPN gateway to allow partners to access into your VNet, and by that way connect over your private link to your database. That's what you could be doing there. And then the second part of the question, or is it just for connection to your own resources? So it's not necessarily. If it's the latter, do you have any suggestions to take access to the API so that only your partners can use it? those are using Azure as well. And so you could be using, you could be doing connections between VNets. If that's in Azure, that should actually work. Using the VPN gateways in Azure, you could do that. You could also go for the IP restrictions on an Azure web app, so that you don't lock it down to just one virtual network, but you lock it down to your virtual network. And then you could also allow particular IP addresses of your partners. That's probably the easiest approach. But it does mean you have to keep your IP addresses, your blacklist, whitelist, allow deny list up to date. Active firewall sounds expensive, inefficient for large scale ops. Yeah, firewalls are expensive. That's true. They are expensive. They're complex. So I would only kind of add them if you really need to. It's always a balance between cost, amount of work, and security. So it all depends on how secure you want to be and how much money are you allowed to pay for it. Do you have any suggestion for centralized log collection monitoring at Azure? Are all the other logs available by default, or do you need to enable any of them yourself? That's a good question. Azure has the Azure Monitor, and that also has a central place for you to store your logs. So you could actually do that in Azure. If you would, for example, log all of the stuff that goes in and out of your virtual network, you need to configure that. That's not something that's on by default. So you will need to turn it on. And if you do that, then you also get to pick for how long you want to store your data, etc., etc. But it is something you can do in Azure. And it's quite easy to actually set up.
I think that, like with the scans and stuff, was to the previous one. And last question is there a way to predict pricing impact of various security solutions before you enable them?
Yes, I would say yes. I mean, the first thing you can do is go to the Azure pricing calculator, and you could use that to calculate your costs. I know from experience that can be quite hard, because sometimes you need to know how many requests you're going to serve, or how much data are you going to serve, how much bytes are they going to go in and out of the network. So it's not easy, but it can be done using the pricing calculator. Some other option is what I've used in the past to get some prediction in place is to do some of these things in a test environment, let that run for a while, and then use the Azure cost analysis on that particular resource to see what that will cost. And if you then know the amount of traffic on your test environment and the amount of traffic on your production environment, it's quite easy to do a prediction there on the actual cost. And you even get a prediction in the Azure cost analyzer by default. So if you have it turned on for a week, it's already capable of showing you what your cost will be in a month, for example. Yeah, thank you as well for joining, Andrew, and for the nice questions.
Yeah. So I think we can wait for a minute if somebody else asks any question, but in general, I think we are good to close. So yeah, I thank you, Erwin and Jan, again for your presentation. Thank you for joining us.